Record progress.
Hey everybody, this is Dr. Jacobs. Welcome to Chapter 9, Conducting Experiments. Throughout this unit, there's some things that I'd like you to be able to do. I want you to be able to explain the differences between straightforward and staged manipulations of an independent variable. I want you to be able to distinguish among the three types of dependent variables: self-report, behavioral, and physiological. I want you to be able to discuss the sensitivity of a dependent variable, contrasting floor effects and ceiling effects. I want you to describe ways to control participant expectations and experimenter expectations. I want you to be able to summarize the reasons for conducting pilot studies. I also want you to be able to describe the advantages of including a manipulation check in an experiment. I want you to be able to explain what the power of a test is and how to increase it. I want you to be able to write, interpret results of statistical analyses. And some of these things are things that you should have learned in your stats class. If not, we'll review some of them here too. All right, so let's get started. So whenever we're conducting a study of some sort, we have to select our research participants. For a little bit of a review, a population consists of all the individuals of interest to the researcher. And a lot of times you actually want to be very careful about who you're selecting for your population, because that can have dramatic effects on whether or not you find significant results in your study. So then your sample is a smaller portion of the population. Typically, books will call that a subset of the population. And it's just a smaller portion that we use to examine whatever we're wanting to study. And then we try to generalize or put those results back onto the overall population. And that's the whole basis for inferential statistics. So we can use probability or non-probability sampling to get our sample from the population of interest. So if we want to be able to generalize our results from our sample back to the population, you have to use random sampling. So in previous statistics classes, if you learned about something called parametric assumptions, or the specific conditions that your data set have to meet in order to run the different analyses that you learn in stats, one of the assumptions that is in almost every inferential statistic is that you randomly selected your sample. Now, a lot of times we don't do that, right? Because we learned that there's other types of sampling methods. And if we don't, then that has some drawbacks to it. So for example, if you use other methods like a convenience sample or snowball sampling, you can only discuss your results with regards to your particular sample. You can't generalize them back to the population. And we'll have a whole unit on generalization as well. So to determine an appropriate sample size, we have to get into a conversation about something called power of the test. And so the power of the test is the probability that you will reject the null hypothesis with the data from your sample if the null hypothesis is incorrect in the overall population. So what this is saying is that you have a big enough sample that you're going to be able to detect that there's significant differences if those significant differences really exist. So when conducting a study, it should be properly powered, they say. And so to do this, there's certain things that you can do to increase the power of your test or increase the likelihood that you'll reject the null if it's false. One of those ways is to increase the sample size. Another way is to increase our alpha level, but you can only do that so much. So if you remember from basic stats, there's two commonly accepted alpha levels. One is 0.05 and the other is 0.01. You can't go above 0.05 because that's just the commonly accepted convention for it, even though there's no science behind those. You can use a one-tailed test. That's another way of saying that you wrote your hypotheses directionally. And then another way is to use a parametric analysis. So probably most likely you learned all parametric analyses in your last stats class or in your first stats class, unless you learned also a chi-square statistic, which is a non-parametric. So this would be an independent samples t-test, dependent samples t-test, one way between groups ANOVA, Pearson product moment correlation, linear regression. So to conduct a power analysis, there is a free software that you can get. It's called G-Power. If you Google it, this is what the page looks like. But if you just put G asterisk power, you can find the software, and then there's some manuals and things that you can look at it. So in order to do a power analysis, you have to have information about what statistical analysis you're using, how big you think the effect size is going to be, if you wrote your hypotheses directionally or non-directionally, and then what your alpha level is. And when you put the information into it, then it'll pop out what your minimum sample size has to be in order for it to be properly powered. So a lot of people will say that you should power your study up to 0.80 or 80%. So that's proportion form. So 80%. For me as a researcher, I probably go overboard, but I'm like, wow. I mean, if there's only an 80% chance that I'm going to find significant results, if those significant results exist, as a researcher, you want to find significant results. There's a bias within the scientific literature to only publish research that's statistically significant. And that's a whole different soapbox for me, because I think that's actually skewing our data and skewing the information that's out there. But for me as a researcher, I like to power my studies up to 0.95 or 95%, which leaves only about a 5% chance that I'm going to make a type 2 error. Okay, so ethics in research, it's actually unethical to conduct an underpowered study. There are some caveats to this. If you're doing a pilot study, which we'll talk about in a little bit later, where you're just trying to test out your procedures and stuff, that's okay. But if you're trying to do a full-on study, if you don't have a fully powered study, if your sample size is not big enough, you're actually wasting your participants' time and energy, and you're not going to really add anything to the literature, the scientific literature. So again, this means that rather than guess about how many participants you need, that you need to conduct a power analysis. And sometimes G-Power can be a little overwhelming. There are a ton of YouTube videos out there to determine which one to complete. So also, they don't talk about this a lot. You can actually have too big of a sample. So you might be, oh, I'll just say I need 400 participants then. Well, actually, that's not good either, because if you get too big of a sample, you can basically just sneeze and you're gonna have statistically significant results, because the bigger the sample, the smaller the differences need to be between groups. If you remember from statistics class, just because we have statistically significant results doesn't mean those differences are meaningful. And we would do a follow-up analysis called an effect size usually to examine how big those differences are. So independent variables, for your study, you're going to need to operationally define the independent variable. And so that just means like, okay, so how are you going to identify which group's which? Straightforward manipulations, independent variable. These are basically where you have instructions for it, stimulus presentations, you just put them into groups, things like that. It's really straightforward. There's no deceit. Most independent variables in studies are going to be straightforward manipulations. However, there are also stage manipulations. So this could be staging events during the course of a study. I remember hearing about a study that was done at a local college here, that they had participants in a study, they were filling out forms, and then they would have a Confederate, which we'll talk about what that means in a minute. Actually, let's talk about that now and we'll go on. So a Confederate appears to be another participant in the experiment or just a bystander or something, but they're actually a member of the study team. Okay, so or they're actually the manipulation. So for example, the study I was telling you about, they had participants in a room, they had the door open, participants were filling out forms that they thought were part of the study. They had the Confederate walk along the hallway and then fall on the ground. And so what the manipulation was is sometimes the Confederate was dressed in professional clothes with heels and makeup, and then other times the Confederate were in sweatpants. And what they found is that people were more likely to help the person who was dressed up. Mind you, these participants didn't know that was actually the study to see if they would go and help the individual. And I thought that was it was a brilliant study to read. So strong manipulation. So a strong manipulation maximizes the differences between two groups and increases the chance that the independent variable will have a statistically significant effect on the dependent variable. So they said, especially within, like the book was saying, especially within initial research, you want the groups to be really different or have a really big difference between them so that we have a better chance at seeing if there are statistically significant results. Doesn't mean that in follow-up studies you can't make those differences a little bit closer, but they're saying anytime that you're entering into a new field of research to try to make them really big differences. So measuring the dependent variable, and we've gone over a lot of information about this already, but this is also revisited in this unit. Self-reports are where participants provide information on their experiences. So for example, thoughts, feelings, behaviors. Behavioral measures are direct observations of behavior. So this could be if you're in a classroom and you wanted to see how many times a student is off task, you would operationally define what it means to be off task. And every time the student was off task, you would mark it on your sheet. Then we have physiological measures, which are recording the responses of the body. So for example, the EEG, I know that we have an EEG lab here at UCM. And that's a really great way for students to get involved with physiological measures. Sometimes people will have like a sweat response. Sometimes people will measure cortisol or the stress hormone to see different reactions to things. So our dependent variable, remember, whatever measure we use, a measure is a tool that we use to turn information into numbers. And so our dependent variable has some sort of measure so that we can get numbers so that we can analyze it with statistical analyses. So with our dependent variable or in measures, whenever we hear the term sensitivity, this just means how easy how easily that measure picks up the differences in participants. So if we have a measure that's not sensitive, we're not going to see a lot of variation, and that's going to make it really hard to do our study. And sometimes this can cause some problems. And I'm going to tell you all about the problems I've had in research. Like I tell you all the time, there's no perfect study. The only way to learn research is to do it, and honestly, to mess up and learn from it. So we have something also called a ceiling effect, which is when most participants score really highly on a measure with not a lot of variation. And then floor effects is when most participants score really lowly on a measure. And so, for example, I did a study examining the suicide warning signs. And when I did this, I just used a college sample because that was a convenient sample. It was easy to access. I thought it would be great. And I wanted to use it to look at differences in the suicide warning signs between people who had suicidal thoughts versus not. And when I did it, it had such a floor effect because most of the people that I solicited for the study did not actually have any suicidal thoughts or behaviors. And so what that did is that gave my my distribution a positive skew to it, and so that normal distribution that we need in order to run a lot of the analyses that we need. And so I just learned that, okay, in the future, I really need to narrow down the population. So when I'm defining that population, I probably shouldn't just do a regular college student population. I probably should look at people who have a history of suicidal thoughts and behaviors, maybe even non-fatal suicide attempts as well. So finding measures, the best way to do it is reading articles, finding measures that were used in previous studies, and then finding those measures. There's a couple different ways that you can find measures. Sometimes you just have to ask the corresponding author permission. So anytime that you're reading an article, a peer-reviewed journal article will have a corresponding author with their email on it. Sometimes it can be really hard to track down some of these people because they move different institutions after they've published. But for the most part, I don't think I've ever had someone tell me no. If this ever becomes a thing where you want to ask an author for permission to use their measure, you want to make sure that you do it professionally. Be like, dear blah, 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 comma, my name is so-and-so. And if you're a student, I'm under the supervision of Dr. blank, blank, blank. I read about your measure and cite the article and was wondering if I could have permission to use your measure for I can't think of the word right now. So it's where you make no money. It's not nonprofit, but it's something similar, but basically research for educational purposes that's not going to make money. And if you are going to make money, you can't say that, but if you're not making money, usually people will let you use their measure for free. It's really important though that you're able to find the reliability and validity information for those measures, because just because they're already made doesn't mean they're strong measures, which is why it's better to read articles and see what's being used, especially if it's across multiple studies, so that you can get quality measures. Another way that you can find measures is using APA PsycTest. This is one of those databases that we learned about this semester, and you can just go to the JCKL website, and then you can look up APA PsycTest, and then you can go in and search different items. You're always going to want to endorse full text available, which will give you typically the items, but the items are the questions that we're asking. So if it's a self-report, if it's on depression, it might be, how many times have you cried without reason in the last 2 weeks, right? So that's one of the items on the measure. The measure would be some sort of depression inventory. And so you can find some this way. Sometimes there's some good things, sometimes there's not. You always have to evaluate them based on the criteria that we learned about earlier about what makes a good measure and quality. So review demand characteristics makes its way back into this lecture. So again, experimenters generally do not wish to inform participants about the specific hypotheses being studied or the exact purpose of the research. Most students forget this when creating their informed consent form. So if you remember from our ethics unit, that we have to have an informed consent that basically tells people or participants what the risks and benefits of participating in the study is. You want to be very vague. You do not want to tip off students to what the study is exactly about, because then those can serve as demand characteristics. And so if we remember, a demand characteristic is any feature of an experiment that might inform the participants of the purpose of the study. Okay, so that's really interesting, because sometimes we're going to be using deception. I've never actually used deception in a study yet, but sometimes we might use deception in a study. And if you're doing informed consent, you can't tell them you're using deception. But if that happens and you do use it in a study, you'd have to disclose that in debriefing. So we can use deception to conceal the hypothesis, but you have to disclose it in debriefing, which happens after the conclusion of the experiment or the study. So one way that you can use deception, you can make up a story about what you're examining. If you all remember from other classes learning about the Milgram experiment, they told the participants in that study that they would be examining the learning and things like that, but actually what they were looking at was people's if they would listen to authority or not, even to do terrific things. And when I say terrific, not like good, like terrifying things, because they were trying to examine how could people who see themselves as good, or people who society would see as good, turn into what we saw with World War II in Nazi Germany. How can all those people do these things? And so they were actually looking at authority and people's compliance to authority. Another way to do it is to add filler questions in with the other questions that are actually that you want to know. And so that helps kind of conceal what the study is actually about. We also learn about placebo groups, and you don't need to write that article down or anything, but we're going to talk about it in a minute. And this is simply providing attention. We have placebo groups because we know that simply providing attention and contacting the participants actually possibly influence the results from a study. Y'all probably have heard of the placebo effect, where if someone believes in the pill that they're taking, even if there's no actual effects to it, they see improvement in whatever symptoms, or they report improvement. So sometimes we'll have regular placebos. These are where, like, it could be a sugar pill that has no effect or side effects, and people take it and nothing happens. We also see something called active placebos, and these actually are no effects except for mimic side effects. And that's, some people really don't like that. So like if the regular medication would give you dry mouth, the active placebo would have no other effects except for the dry mouth. And this helps participants not know which condition they're in at all, or they might think they're in the intervention group and not have any idea. So with this, there was one study done where they were examining how effective arthroscopies were for knee surgery. And so the treatment group had the arthroscopy, and then the placebo group, they had an active placebo where they basically used a fast acting anesthetic. They did a tiny little incision, actually didn't do the surgery, sewed them back up. And what they found is there was no difference between the people who had the arthroscopy surgery and the ones who had the active placebo. And both groups saw improvements, but there was no significant difference between the groups. And so some people are like, can they do that? They did. And actually, if you have participants knowing that they could potentially be in either group and they don't know which group they're going to be in, it's ethical. And some people are like, well, but they didn't get the surgery. Well, we found there was no difference between them, right? So we can't, I mean, we could, like, if we were giving surgeries and things, we probably already know if they're actually working or not. And here we're seeing they didn't have to go in and do all those invasive things. They just did this really quick incision, made them think about it, and then they got better, right? So expectancy effects, several studies showed that inducing expectancies in experimenters who ran the subjects through various laboratory conditions could influence the results. So if the person conducting the study knew what they wanted to happen or knew what the hypotheses were, we saw that that in itself could influence the results of the participants. Sometimes we hear this called the Pygmalion effect or the Rosenthal effect. And this original research occurred in classrooms and demonstrated that teacher expectations influence student achievement. So what they did with this study was they had this IQ type test that showed which students would have dramatic growth. And it was fake. It was not real at all. And they'd be like, this student, they're going to do great. They're destined for great things. The placebo group, oh, they're like, no, it's not that. And what they found is because the groups were equivalent, the students who had the teachers who believed that they were gifted or would be more talented actually performed better than the students who didn't. And they then did something sneaky. They said, oh no, actually we messed up. This is the group. And then we saw the same thing happen. So then the other group started achieving more and this group didn't achieve as much. And this is why within a lot of college of education programs, we see that they say teachers should have high expectations for their students because often they're going to meet it. Okay, so one way to try to control for expectancy effects is to automate as many procedures as you possibly can. So if you're doing online research, that makes sense. If you have a thing where you're going to be into contact with participants, then you're going to want a script for your study so that you read it the same exactly every time. So other ways to control for expectancy effects, you can do a single blind study. This is where the participant's not aware of whether they're getting a placebo or the actual drug. If that is a psychological intervention, then you would have to give something to the participants that gives the time and attention to those participants like they do with the people in the treatment group, because otherwise they're going to find out real quick that they're the placebo group. Then in a double blind study, neither the participant or the experimenter know which is the placebo or actual treatment. And to do this, then the experimenter or the researcher then would have to hire other people to implement the things. And that always comes at a cost, right? That would be a financial cost. That's a time cost because you're gonna have to train those people. And so that can complicate things as well. The book also talked about pilot studies, and a pilot study is a trial done with a small number of participants. One reason that you'd want to do this is you'd want to be able to work out some kinks in the procedures before implementing a larger study. Sometimes people will do a pilot study when examining measures because measure development is really hard. So then you can also do manipulation checks, and a manipulation check is an attempt to directly measure whether the independent variable manipulation has the intended effect on participants. So the book had a few examples of this. If we're looking at attractiveness groups and seeing if people rate them higher on whatever quality, we can say niceness, we'd actually have to check at some point that participants actually thought those people were attractive. So people or scientists are kind of mixed on whether to use manipulation checks or not. Some scientists think that this could become a demand characteristic for the study and then alter the results. So if you ask people, do you think they're attractive or rate their attractiveness? Well, then like, oh, we're looking at attractiveness in the study. But it also could save money and time if the manipulation actually isn't effective before you do anything major with it. And also if you don't find significant results, then manipulation checks can provide additional information, like were they actually strong manipulations? Were they accurate? Debriefing then, this is an opportunity for the researcher to interact with participants to discuss the ethical and educational implications of a study. So if you're doing a study in person, let's talk about that example that was from one of the local universities around here where that study was, where they had the participants in the room and they kept having the Confederate fall down. In the debriefing meeting, you would actually talk to participants and say, hey, actually, the study wasn't about the measures you were filling out. We were just curious if you would help the people off the floor if they were dressed a certain way. Sometimes people ask the participants what they believe the purpose of the study was, ask about the manipulation, and then often we'll tell participants don't talk about the study to other people because if that gets around, then that serves as a demand characteristic as well. Also, if you use deception, you would discuss this with the participants at that time. So analyzing and interpreting results. After we collect data, we analyze it using statistical techniques. This is what you learned to do in your statistics course. That was prereq to this class. So if you had trouble in stats or you don't remember, because it's something that you just have to keep practicing, you're always welcome to come into my office hours if you need help with anything. All right, so when we're writing our results, there's a common format. This is not what it would look like exactly for every group, but there's some things that are the same. So here we have a T first. T represents which test statistic we use to analyze the data. In this sense, that is a T test. T does not mean test statistic. T is a type of test statistic. If you use an ANOVA, the test statistic is F. If you use a one sample Z-test, your test statistic is Z. If you're using a Pearson product moment correlation, your test statistic is lowercase r, okay? So anytime that you're reading results in a manuscript and you see that first letter, that's telling you which analysis they did or what group of analyses they did. After that, we see the degrees of freedom, which we know is related to sample size. Then after that, you see the test statistic. This is a value that you calculate with your data set using whatever formula that is associated with the analysis that you're using. The P then represents the p-value or the probability of making a type 1 error. If you are using a statistical software, it'll give you your p-value. To have statistically significant results, we want our p-value to be less than our alpha level. We mentioned earlier, there's two common alpha levels. One's 0.05, the other's 0.01. And we always want to have significant results. So the p-value has to be less than that alpha level. If you don't have significant results, then the p would equal n dot s dot. So after we conduct research, we also want to communicate research to others. There's several ways to do this. You can do it in journal articles, professional conferences. That's something my lab does a lot. And there's also some popular ways you can do it now. Podcasts, you could do popular source articles for magazines or radio stations. And that's all we've got for this week. So if you have any questions, please let me know. We're moving right along.